So today we're going to do section 2.2. And it's all about intercepts and an idea of symmetry. So intercepts, I'm pretty sure you know about. Symmetry might be totally new for you. So we're going to take a look at it in terms of small chunks. We want to make sure you understand it. So our first example we're going to do, what we want to do is we want to determine which of the given points are on the graph. Okay, so they're not going to give me a graph. What they're going to do is give me an equation. And this specific equation is y equals x to the fourth minus the square root of x. Now, when I look at that, I have no idea what that graph looks like. I don't know at all. And we will actually not graph anything that looks this ugly in our course. But we want to know whether or not the point 0, 0 is on that graph. So without graphing it, how can I determine whether or not this point lies on the picture of that graph? Well, we know that this is the x coordinate. We know this is the y coordinate of a point. If 0, 0 is on this graph, then plugging 0 in for x and 0 in for y should give us a true statement. So we're simply going to come in and replace the x and y with the numbers. So they'll tell me that y is 0. That's going to be equal to 0 to the fourth power minus the square root of 0. Well, 0 to the fourth power is 0. Square root of 0 is 0. And sure enough, 0 equals 0. So that means at this point, 0, 0 is on the graph. Let's do one more point just to make sure you understand. 0, 0 wasn't very exciting because everything's a 0. So let's try another point. Let's go ahead and use 1, 1. So part B. Let's test and see whether or not 1, 1 is on that graph. So I'm going to do the same thing. I'm going to replace x with 1 and y with 1. So is 1 equal to 1 to the fourth power minus the square root of 1? Well, that's 1. 1 to the fourth power is 1. Square root of 1 is 1. So 1 does not equal 0. So no, 1, 1 is not on the graph. And these problems are designed just to give you an idea of whether or not you understand what you're plugging in for x and what you're plugging in for y. So you're going to do 1 or 2 of them just to get some practice at plugging the values in for both the x and the y. Good. The next thing I want to talk about is the idea of intercepts. So do you know how to find the intercepts for any equation and then to graph equations? So our second example, we're going to come in and find the intercepts. And graph the equation. And this is where I really can tell how much background you've got. So the first one we're going to do is y equals 3x minus 9. So y equals 3x minus 9. So when you look at that, you should already recognize what that graph looks like because of your prior algebra work. So what we're going to notice is this is a linear equation. And what that means is that all the exponents on the variables are 1. And specifically a positive 1. And that's what makes it a linear equation. Well, that means it's a line. So we know that when we finish this one, we're going to have a graph of a line. So to find the x-intercept, this is the place where the graph crosses the x-axis. We're going to come in and replace y with 0. Because if I'm on top of the x-axis, the y value is 0. And solve. So that means 0 equals 3x minus 9. We'll move our 9 over. That'll give me 3x equals 9. And then dividing by 3 is going to give me 3. So the x-intercept is 3. Always write this as a point. So this is the point 3, 0. Again, we replaced y with 0. We got an x value of 3. So we know the graph is going to cross the x-axis at a positive 3. Now we'll go find the y-intercept. So part B, or the second part of that one, we'll do the same thing but replace the opposite letter. So to find the y-intercept, we'll replace x with 0. And solve. That should make sense to you, because again, if I'm crossing the y-axis, then the x value is going to be 0. And I see that I've run out of room, so I'm going to come right up here. So we'll have y equals 3 times 0 minus 9. You can almost do this in your head. The 3 times the 0 is going to be 0. That just gives me negative 9. So we know the y-intercept is the point 0, negative 9. Okay, well, now that I have those 2 points, because I know it's a line, I know that those are enough to be able to graph it. 2 points define a line, so we can come in and graph that. So on the x-axis, we're at positive 3. On the y-axis, I'm clear down there at negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can draw in your equation. So that's y, and there's our x. And if you've never played with that graphing tool in the MyLab Math, you might want to make sure that you save yourself some time, because it's a little challenging to get used to how to plot those points and then connect them. So our first examples of line, we do that because the variables had exponents of positive 1. You replace y with 0 to get the x-intercept. You replace x with 0 to get the y-intercept. You replace the opposite letter. And then once you've got those, because it's a line, you can just graph those 2 points, draw in your line. That was a nice one. Good to start with. Now let's go do something a little bit more challenging. So non-lines. So something that's non-linear is a curve. So let's go graph a curve. And for some of you, this may be the first time. Although if you came through our 101 course, you've graphed curves before. So the second one we're going to deal with is 4x squared plus y, and we're going to set that equal to 4. Now, the ones you're going to be doing are fairly gentle equations. They're not going to give you anything really ugly. Okay, because we see an exponent of 2, we know that this is not a line. This is a curve. And to graph a curve, we may need a lot more than just those 2, the intercepts, so just 2 points. We are going to come in and find the intercepts the same way. Let's go find the x-intercept first. So again, we replace y with 0. So that would give me 4x squared plus 0 equals 4. That's just 4x squared equal to 4. And then we'll divide both sides by 4. I'll get x squared is equal to 1, and then we'll square root. So x equals plus or minus the square root of 1, which is 1. So I end up with 2 x-intercepts. One of them is at positive 1, 0. The other one is at negative 1, 0. Okay, I'm actually going to go plot those right off the bat to kind of get an idea of what's going on here. So I know that on the x-axis, I have an intercept at positive 1 and one at negative 1. That definitely tells me it's not a line. Okay, let's go find the y-intercept. Again, you replace the opposite letter with 0, so that means the x is now 0, so that would be 4 times 0 squared plus y is equal to 4. That just gives me 0, so I'll get y equals 4, which gives me the point 0, 4. So right now we've got 3 points. And now we can talk about, if you know what kind of curve it is, you could draw it in. If that's not enough to give you an idea of what it is, you could always pick more points. So you can build an XY table for more points. It just depends on whether or not you need more points. So if I want to do that, let's come in and plug in, I don't know, positive 2 and a negative 2, just to get an idea of what's going on. So I'm going to try and do this verbally, see if this works. If I plug in a positive 2, 2 squared is 4. 4 times 4 is 16. That would give me 16 plus y is equal to 4. Or when I move that over, I'm going to get y equals a negative 12. That doesn't make sense. Plugging in 2. Okay, so somewhere I've made a mistake, or I'm really messing up first thing in the morning, which happens, believe me, first thing in the morning. If I plug in a positive 2, so I'm talking about plugging in this number, we should be getting a positive y unless I've made some sign errors someplace, but I don't see any sign errors. Because if I move my 16 over, I'm going to get y equals a -12, which is not a correct point. I know that because this thing's a parabola. I've got an x squared on it. Y is equal to 4 minus 4x squared. So we replace the y with 0, we're going to get plus or minus 1. If we replace x with 0, we get y equals 4. Not coming out with where my mistake came into play. Still getting negatives. Oh, duh. You guys should have caught this. Somebody should have caught this. This is me. I'm dyslexic. I didn't give you guys a disclaimer. +4 is up, not down. Don't do that kind of thing. It makes a mistake. But by plotting extra points, I could tell that I was making a mistake. So we're going to get a -12 over here, which is going to give me a point way down here for that 2. I just can't plot points. If I plug in a -2, I'm going to also end up with the same exact value. -2 squared is a +4. 4 times 4 is 16. Moving it over is going to give me that same -12. So I'll get another point over here at -12 for -2. And that gives us our shape. So we end up with something that's called a parabola. So this U shape is called a parabola. And it's going to happen anytime you have one of the variables squared. So if you have an x squared or a y squared, you'll end up with a U shape. If the x is squared, it's going to either open up or down. If the y is squared, it opens left or right. So, okay, sorry about that. Sometimes I just plot things in the wrong place because of my dyslexia. So, okay, whew, made it through that one. So that's how you find the intercepts and graph the equation. You'll do a couple of those problems. They're kind of fun just because you'll see some graphs that you haven't maybe graphed in a while or before. The next thing we need to talk about is the idea of symmetry. In your textbook uses symmetry to help us graph equations. So symmetry means that something is identical on both halves. So ideally your body is symmetrical from the left side to the right side. There are lots of things that exhibit symmetry. For algebra, we look at 3 types of symmetry. So we're going to look at symmetry with respect to the x-axis. We'll also look at symmetry with respect to the y-axis. And then finally, we're going to look at symmetry with respect to the origin. So meaning the point 0, 0 with respect to the origin. So let's draw some graphs to help us with this idea of symmetry. So if something has symmetry with respect to the x-axis, what that basically means is that you can take your shape and fold it across the x-axis. So if I pick a random point, x comma y, also on that graph is x comma -y. So in other words, it folds over the x-axis and folds onto itself. So that would be a graph that has symmetry with respect to the x-axis. So what we're going to notice is that if we replace y with -y, the graph does not change. So it's simply saying that for every x coordinate, there's both a positive y and a negative y that have that same x value. Okay, that makes sense from the picture point of view. For the y-axis, we're going to do the same kind of thing. I'm going to use a different picture, obviously. So in this case, we can see that the graph folds across the y-axis. So the y-axis is basically your fold line. The left side would fold to the right, or the right would fold to the left. We can do the same idea in terms of points. So if I come up and pick a point, it's at x comma y in quadrant 1. And over here in quadrant 2, I have to have a -x and a positive y value again. So this is saying that if we replace x with -x, the graph does not change. So in other words, for every point that's in the first quadrant, you're going to have a matching point over in the second quadrant. Now, my 2 graphs, we picked on the first quadrant as our starting point, but again, you could have something that's down here doing the same thing. And that's symmetry with respect to the y-axis. We will talk about this a lot as we move forward in the class. Origin, well, that's a different one. So what we're going to do this time is draw a much different shape. It's going to look something like that. So we call this an S shape, even though it doesn't really look like it. It's an S shape. This would be a V shape. This is our parabola that we just talked about. Again, I'll pick a point in that first quadrant. We're going to call it X, comma, Y. So in order for this to have symmetry to the X-axis, to the origin, you have to be able to double fold. Double fold means you go across both axes. So in other words, if I fold across the X-axis first, that would fold this piece down into this quadrant. And then if I fold this over to this quadrant, we'll see that sure enough, this is going to fold right on top of this. The corresponding point over in this quadrant, though, is a negative X and a negative Y. So notice the signs on both the X and the Y coordinate change. And that gives you something that has symmetry with respect to the origin. So we'll say you can replace X with negative X. And Y with negative Y. And the graph does not change. So the statements that we've written down here are basically what we're going to use as our tests for symmetry. So this is how we're going to test whether or not an equation has symmetry. So if I want to know whether or not it has symmetry with respect to the X-axis, I'm going to replace Y with a negative Y. If I want to test the symmetry to the Y-axis, I'll replace X with a negative X. And if I want to test to the origin, I'm going to replace both X and Y's with a negative X and a negative Y and see what happens to the equation. Again, several of you are moving on into pre-calc in the fall. You'll use this idea again in pre-calc. So some of you, luckily, like Christina, is headed into biology. She's done with it after this class. So her applied calc doesn't use this. So now that we have some idea about what symmetry means, we're going to take an equation and test for symmetry. I'll leave that over there in case you're not quite done. So our next example, this is example 3. It's going to ask us to list the intercepts and test for symmetry. So list the intercepts and test for symmetry. Okay, so the first one we're going to start off with is y squared equals x plus 9. So y squared equals x plus 9. So they're having us do the same thing that we did in the previous examples and adding on to that by having us test for symmetry. So they're kind of a long-winded problem. It's got multiple parts to it. So let's go find the x-intercept first. To do that, we're going to set the y to 0. So 0 equals x plus 9. If we move the 9, we'll get a negative 9. So we know that the x-intercept is negative 9, comma 0. Find the y-intercept. We'll replace the x with a 0. That'll give me y squared equals 9. When we square root both sides, we get y equals the square root of 9, which is 3. And because you're solving, you tack that plus or minus on. So we have two y-intercepts. I have 0, 3, and I also have 0, negative 3. Now, in class, I'm really picky about how you write those intercepts. So please make sure anything that you turn into me physically as a written work, you write those intercepts the correct way. I don't know how picky my lab math is about it. I have a feeling that it gives you a template and you're plugging in the number. So, okay, so that was the first part. That was the easy part. We'd already worked on that. Now let's come in and test for symmetry. And you have to do 3 different tests. So for the symmetry, we're going to do the x-axis first. Why? Just because it's alphabetically before y-axis, I guess. So we'll do the x-axis first. So again, what we're going to do is we're going to replace y with negative y. So you always replace the opposite letter, which is really nice because it mirrors what we did over here for the intercepts. To find the intercepts, we replace the opposite letter with 0. Here, we're going to replace the opposite letter or variable with a negative y. So in our equation, we're going to have a negative y squared, and that's going to be equal to x plus 9. So all I did is I took my beginning equation, I replaced that y with a negative y. Now I need to clean that up. So a negative y squared is a positive y squared. So I end up with a y squared equals x plus 9. Now what I want to do is I want to compare that to the original. And here's the original sitting back over here. So this is the original equation. And I want to compare those two. And what we're going to notice is there's no change. It's exactly the same. So because there was no change, we have symmetry. And this is actually being backed up by the fact that we have two y-intercepts. So what we're saying from the y-intercepts is because we're crossing the y-axis at the y-axis at -3 and also again at +3, you can see that those guys are mirror images of each other. So that leads me to believe that yes, we have symmetry over the x-axis. So that's why they had you find the intercepts, is to kind of help with this idea over here. Okay, now let's go test for the y-axis. And again, what we're going to do is replace the opposite variable. So we're going to replace x with -x and see what happens. So I go back to my equation, y squared. Wherever there's an x, I'm going to write a -x and see what happens. So I end up with y squared equals -x plus 9. Well, I don't really need the parentheses there. That would just be y squared equals -x plus 9. Now I want to compare that to the original. And when I compare that to the original, it is not the same. It has changed. So it's not the same as original. So that means there's no symmetry to the y-axis. So because the equation changed, that tells you don't have a mirror image point on the other side of the y-axis. And we knew that from the x-intercept because there was only one of those. So, okay, and then to test for the origin, you replace both. So let's take our original equation. We're going to replace y with a negative, and we'll replace x with a negative. Now, let the problem work for you. You've already done this in two different forms. So we already know that when we replace the y with a negative, that we end up with just a y squared. We would know when we replace an x with a negative, it keeps it as a -x. So here's the result. And when I compare that to the original, it's not the same. Which again tells me no symmetry. So I cannot fold this thing across the origin. I can't do a double fold and have it fold onto itself. Now, you cannot make assumptions here. So just because it has a no symmetry for the x and a no symmetry for the y doesn't mean it might not have symmetry for the origin. So you really do have to do all three tests. Let's walk through that again because I think that's a little bit vague and you've probably never done it before. So symmetry to the x-axis, you're going to replace y with a -y. Clean up the result of that equation. And then if there's no change, then you know you have symmetry. For the y-axis, you replace the opposite variable x with a -x. Clean it up. If there's no change, you have symmetry. If it's changed, there is no symmetry. So again, what you're after is those mirror image points. So back over here, when we replace for the origin, you replace both the x and the y with a -x and a -y. And we see that we do definitely have a change in the equation. So it's not the same as the original, which means no symmetry. So it's kind of a weird test because you're looking for something to have no change for it to have symmetry. Okay, let's do another one because I think these you need a lot of examples on. Is everybody good to go with this one?
Yes.
Okay. So the idea of symmetry is that if you know something has a specific symmetry, then you can just draw half of the picture and use the idea of symmetry to do the other half of the picture. Okay, so the one I want to do now is I'm going to do one of the fraction ones. So let's do y equals x squared minus 4 all over 2x. Okay, let's find the intercepts first. So x-intercept, we're going to set the function equal to, the equation equal to 0. So that would be x squared minus 4 all over 2x is now equal to 0. Ooh, we haven't solved anything like that. So let's come in and clear the fraction. So we're going to multiply everything by the common denominator, which is that 2x. On the left side, 2x times 0 is still 0. On the right side, the 2x is going to cancel completely, and we just have x squared minus 4. So we'll get x squared equals 4, and then we'll square root both sides. So I get plus or minus 2. So in terms of x-intercepts, let's just start writing all the information someplace where I can keep it. I have a positive 2, 0, and I have a negative 2, 0. And that right there already tells me something about the y-axis symmetry. Because again, what we're saying is that the graph itself, without graphing it, we have something on the left side, something on the right side that are mirror images of each other. So we can see that we probably have symmetry to the y-axis when we test it. Let's do the y-intercept. The y-intercept says replace all those x's with zeros. So y is going to be equal to 0 squared minus 4 all over 2 times 0. So 0 squared minus 4 is a negative 4, but 2 times 0 is 0, and we cannot divide by 0. You can't take something and divide it amongst 0 people. So this is undefined, which means that we have no y-intercept. So the y-intercept is none. So this thing doesn't cross the y-axis. That's all it's telling me. It doesn't touch that y-axis. That's not very helpful in terms of symmetry. So, okay, then we're going to come in and do, whoops, I just erased my equation. Don't do that. We're going to come in and test for the symmetry. So again, the equation was y equals x squared minus 4 over 2x. Okay, so let's do the x-axis first. That means the y is now a negative. That's equal to x squared minus 4 all over 2x. And I want to compare what we just got with the original, and sure enough, it's not the same because the y is now negative. So no symmetry to the x-axis, and that's because the equation has changed. So this thing does not fold over the x-axis top to bottom. Okay, we kind of can see that. We don't have anything up here that tells us it would, so that makes some sense. Okay, y-axis, we're pretty sure it's going to come out as a yes, but we have to prove it. So we're going to replace all the x's with a negative. So y is going to be equal to 2, I'm sorry. Negative x squared minus 4 all over 2 times a negative x. Okay, let's clean that up. When I take a negative number and square it, it's going to be a positive. So I still keep the x, but now it's squared as a positive. It's going to be over negative 2x. Okay, that looks a little goofy. Let's go ahead and pull the negative out in front and write that as a negative of the fraction. So I get y equal a negative of x squared minus 4 over 2x. And you can do that because, again, when you have a negative fraction, you either write the negative on the numerator, the denominator, or on the bar. So we took it from the denominator and wrote it on the bar. Well, that is not the same as the original. So again, I'm comparing this, what we just got, with my original, which is sitting back over here. It's not the same. Huh. Well, that was misleading in terms of those intercepts. Let's figure out what's going on. So we're going to write no symmetry to the y-axis. Now we have not made a mistake. It's coming out exactly like we think it will. Let's go test the origin then. So if this thing's not folding over the y-axis, is it folding over the origin? So our third test is for the origin. In this case, you replace both x and y with negatives. That would give me negative y equals a negative x squared minus 4 all over 2 times a negative x. Again, I'm going to let the problem work for me. I already know that when I clean up the right side, it becomes a negative of x squared minus 4 over 2x. Okay, what you're going to notice for the first time is that you end up with negatives on both sides of those equations. And because you have a negative on both sides, you can actually just divide it out. So we're going to divide by that negative 1, and that'll give me y equals x squared minus 4 over 2x. And when I compare that to the original, it's the same. So that means that I have symmetry to the origin. I knew I had to have some kind of symmetry because what happened with those x-intercepts. So this is simply saying whatever this graph is, you can double fold it. So you can fold it across the x-axis and then across the y-axis or the other order. And sure enough, it folds onto itself. So, okay, so the idea of symmetry is kind of important for us. I did make sure I put one of them on the quiz for the week, but I did not pick a fraction. I picked one of the ones like the first example we did that's a little bit easier on you guys. Okay, and then what your book does is it goes into a whole bunch of problems where they're going to give you the picture and ask you to pull information off the picture. So let's try a couple of those. Is everybody good with that?
I am.
Yay. Hopefully I'm pacing it a little bit better in terms of writing notes and understanding. You're gonna have to figure out how to wash my whiteboard, folks. At school we use a whiteboard cleaner. I don't have any whiteboard cleaner. Okay, so example 4, what we're gonna do is the graph is given. So we're gonna give you a bunch of graphs. We wanna find the intercepts. And this is from the picture, so this won't take as long. And then I want to talk about symmetry. So then tell about symmetry. Okay. So our first picture, so this is part A, is going to look something like this. This is called a hyperbola. It looks like this. So that's a 3. And that's a -3. So we're counting by ones. Yep, it's called a hyperbola. We do graph these in pre-calc, but we don't get to them in 120 just because we don't have enough time. Okay, so from the picture, all we have to do is come in and find the intercept. So you're just reading the picture. So in terms of x-intercepts, we can see that this thing is touching or crossing the x-axis at a +1, and also again a -1. It's this guy over here. What about a y-intercept? Well, does the graph cross the y-axis at all? So none. It doesn't have any y-intercepts. Then let's talk about symmetry. So from the picture itself, we can see that this thing folds over the x-axis. So it has symmetry to the x-axis. But does it have any other symmetry? Well, does it fold across the y-axis also? So it folds from left to right on top of itself. So it also has symmetry to the y-axis. Okay, what about the origin? So in other words, if I take this piece that's right here and fold it down, it folds onto here. And then if I flip it over the y-axis, it's going to fold over here. So sure enough, this actually has all 3 types of symmetry for our class. It has symmetry to the x-axis, the y-axis, and the origin. So it's much easier to do when they give you a picture. So let's do another one of those. So part B is going to look like this. And this is down here at -3. And these guys are at the 2. So it looks something like that. So again, this is called a parabola. And that tells me that in terms of an equation, that either the x or the y is squared, because it's opening up, I know it's the x that's squared. And all that comes just through practice and knowledge that we'll be talking about. So the x-intercepts are given. We can see that it's crossing at +2 and at -2. So 2, 0, and -2, 0. The y-intercept, well, it's touching the y-axis down here at -3. So that would be at 0, -3. And in terms of symmetry, we see that this thing folds across the y-axis, but it does not fold top to bottom, and it doesn't double fold. So I can't fold it top to bottom and then left to right. So the only symmetry it has is the y-axis. So just one type of symmetry here. Comments or questions about that? And do we need to do more of those, or are you comfortable with that? You're gonna do like 3 of them on the homework, I think it is. We're good?
I think I'm all right.
Okay. Okay, you do have one problem on the homework that's gonna ask you to complete the picture using the idea of symmetry. So this would be example 5. Draw a complete graph. So we want to complete the graph. so that we have symmetry to the origin. Okay, and this particular picture, actually, we're going to go for the x-axis, not the origin. I'm going to use the x-axis. Sorry. And this picture looks something like this. It crosses over here at -4. Yep, -4. And this point's up here at 0, 2. -4, 0. Okay. So because we're going to fold across the x-axis, that means we're going to fold this thing top to bottom. So if the point 0, 2 is on the graph, then the point 0, -2 must also be on the graph. And it's going to look something like this. So, and that literally is all you have to do. I think the one that I assigned you guys is symmetry to the origin. So, okay, and then I want to wrap it up with some conceptual type questions just to make sure that you're understanding all the words, because I threw a lot of vocabulary at you today. So given that the point 1, 2 is on the graph, and we know that it has symmetry with respect to the origin, what other point is on the graph? Okay, so I'm going to draw a quick picture just to help me out in terms of what's going on. So I have this point 1, 2, and I know it's on the graph. They also tell me that the graph is symmetric with respect to the origin. So that means that I have to be able to take this point and fold it down across the x-axis and then also across the y-axis. So it's going to end up over here. So I have a corresponding point over here. So if this was at 1, +2, then over here we're going to be at -1, -2, and that's the answer to the question. So the other point that has to be on the graph is -1, -2 in order to have symmetry to the origin. Again, you're not flipping x's and y's at all. All you're doing is changing the sign of the x and changing the sign of the y. So I like these conceptual questions. Number 7, if the graph has, if the graph is symmetric with respect to the y-axis, so symmetry to the y-axis, and 6, 0 is the x-intercept. Name another x-intercept. Okay, what? So again, we'll draw a picture just to help us out. So they're telling me that you've got a point over here on the x-axis at 6. If this thing folds across the y-axis, it folds left to right. So isn't there another point over here at -6, 0? So, which would be the answer to the question. So +6 is an x-intercept, and so is -6. Okay. Number 8. Sorry, these are all over the board. If we have symmetry with respect to the x-axis this time, so x-axis symmetry, and we know that the y-intercept is 0, 2. They want us to ask another y-intercept. So what's the other y-intercept? Again, you're just drawing yourself some quick graphs to make sure you're understanding. 0, 2 is up here. So in order to fold across the x-axis, you have to have the point down here. So if this is at 0, 2, then the answer to the question is 0, -2. And I don't even know that you need to draw a picture to make the problem make sense to you, but it definitely helps. And then the last one is the one I'm desperately trying to get to, or we use up all of our time. So number 8. Says we want to draw a graph that has 2 x-intercepts. So I need 2 x-intercepts. At one, the graph crosses the x-axis, and at the other, it touches the x-axis. So it crosses at one x-intercept, and touches at the other. So the reason I really wanted to get to this one is when we think about intercepts, we think about the fact that the graph has to cross the x-axis there, and that's not true. It's a place where the graph either crosses or touches the x-intercept. So what we're going to do is we're just going to come in and pick, and it doesn't matter where because they don't care. So I'm going to make one of them over here at -3. I'm going to make the other one over here at +5. So there's my two x-intercepts. It needs to cross at one of them. So I'm going to come in and for the one that's on the left side, I'm going to come in and cross that x-intercept. But as I head to the other one, I'm just going to touch. So it's going to come in and bounce at that other intercept. So here's a picture of a graph that crosses at one x-intercept, but touches at the other one, and it's still considered to be an x-intercept. So it does not have to cross to be an intercept. It just has to touch it. So, whew, okay. And I think that is, I have 2, that would have been 9. Sorry, that's example 9. Because I'm looking at the 8 over there. Okay, and that's everything that's in this section. It's got a lot of meat to it in terms of concepts. It doesn't have a lot in terms of actually physically working things out. So, but this isn't due until Saturday, so you've got a couple of days to assimilate it and go back over it. Okay, that wraps up section 2.2. We do not do section 2.3. It's all about lines. We assume that you already know how to graph a line, so we're skipping section 2.3. We'll do 2.4 on Tuesday. Again, no class on Monday for Memorial Day. We'll meet again on Tuesday, whatever date that is for Tuesday. Okay, I'm done with the lecture. I am going to go back and because Rich had asked about that mixture problem with the nuts off the homework, I'm going to come in and take a look at it really quick. So if you want to leave, you're more than welcome to. I am going to stop the recording also so that the sections work out correctly on the YouTube. So I'll just stop the recording.